This is the lesson 7.5 mini lesson. Today I'm going to teach you how to set up, solve, and graph inequalities so that you can visualize your solution set. You will see a lot of parallels between inequalities and solving equations. So our step notes look really similar to what we had when we did 7.2. There's just a few things that make this a little more complicated. So to begin, we start solving the same way. Pretend as if this is an equal sign here. And so I need to isolate my variable. So I'm first doing the inverse of subtraction, so we will be adding 2 to both sides. So this part should be review. We should be able to go through this fairly quickly. So I get 5x. Instead of an equals, I'm bringing down greater than or equal, and I get negative 10. Now I do the inverse of multiplication. So I divide both sides by 5. Divide by 5. And I get x is greater than or equal to negative 2. Okay, so now I need to graph this. If we just graphed that x equals negative 2, I'm going to put 0 here. So negative 2 would be right here. If I did x equals negative 2, I would just put a dot. It's the same thing when it's greater than or equal. My dot needs to be filled in. And I want all the values of x that are greater than negative 2. Greater numbers go this way. So any point that I pick along this line is going to make this inequality true. This side will be greater than or equal to negative 12 if I select anything along here. So I'm going to use a closed circle because it included the equal sign. Now here's how I'm going to verify. I choose a point and I substitute in for the variable. So I'm choosing a point along my graph. I'm just going to tell you that using x as 0, if it's part of your solution set, is a really easy way for us to verify. So I am going to be using x as 0. So I'm going back up here and I'm subbing in 0 for x. 5 times 0 minus 2 is hopefully going to be greater than or equal to negative 12 if I did this right. 5 times 0 is 0. Minus 2 is, again, hopefully bigger or equal to negative 12. 0 minus 2. Negative 2 is greater than or equal. It's not equal, but it has to be one or the other. Negative 2 is greater. Negative 12 would be way out here somewhere. So we solved using our order of operations. Because this is a true statement, I can be fairly certain that this is the right answer. Just to be certain too, you could check negative 2 and plug that in. That should always give you exactly this answer. Okay, let's look at number 2. So this one's just a little more complicated. So when I go to isolate the variable, I have to get rid of the negative 3 and the 4. This isn't attached to the x, so this is first. So I'm doing the inverse of addition. I'm going to be subtracting 4 from both sides. So I get negative 3x less than negative 15. Okay, now I need to do the inverse of multiply, so I'm dividing both sides by negative 3. Divide by negative 3, divide by negative 3. Okay, here's the catch. When dividing by a negative, we need to reverse the inequality symbol. Only when we're dividing by a negative. In that last example, we divided by a positive 5. We don't switch it when we divide by a positive 5, only when we divide by a negative. So this is now going to switch, and a negative divided by a negative is positive. So I want to graph this. So looking at this symbol, it does not include equals. So when I graph, I need to make sure that I'm doing an open circle at 5. So I'm going to put 0 here. 1, 2, 3, 4, 5. So at 5, I have an open circle. X needs to be greater, so it's all the numbers to the right. So in order for me to check this and verify, I verify by choosing a point. I'm going to choose a point along here, and I'm going to substitute it. So I'm going to try to take another even number, so I'm going to try 6. So I'm rewriting negative 3 times 6 plus 4 has to be, hopefully, less than negative 11 if I did this right. So when I keep solving, negative times a positive, I'm following my order of operations. I get negative 18 plus 4 is hopefully going to be less than negative 11. Negative 18 plus 4, signs are different, find the difference. Negative 14 is less than negative 11. This is true, so more than likely, this is the solution. Okay, let's go to the back side. So again, I need to get rid of these two numbers. They're on the same side of my inequality as my x. And I get rid of the one that's not attached to x first. So I'm doing the inverse of subtracting. I'm adding 5 to both sides. Plus 5, plus 5. Negative plus positive, this is negative 3. Greater than equals comes down. X over 4 comes down. This means x divided by 4. I need to do the inverse then of division. I'm multiplying both sides by 4. Remember, this looks like a fraction, so I'm going to multiply by 4 over 1, but over here I'll just multiply by 4. So I get negative 12 is greater than or equal, here I can simplify to show that I get 1x. Okay, so now I'm going to just put my 0 here. I need to go to negative 12. I'm going to go by 2's. Negative 2, 4, 6, 8, 10, 12. Okay, it's a greater than or equal symbol. So it's a closed circle. It includes equals. So at negative 12, I need to fill that dot in. Make sure I can tell which way you're doing that. Now, I'm going to read this starting with my x. I'm not necessarily reading left to right. I need all the numbers that are smaller than or equal to negative 12. Smaller than goes this direction to the left. So there's my graph. I'm going to verify it by choosing a point and substituting. So I'm going to now check. Here's the thing though. Because when I plug in for x, I need to right away divide by 4. I'm going to take a number that would be out this way that can be divided by 4 to give me just another even or an integer answer. I don't want to have to work with fractions and decimals. So I see I could use negative 16, I could use negative 20, I could use negative 24. I'm going to use negative 20. So I'm rewriting negative 8 is hopefully going to be greater than or equal to negative 20 over 4 minus 5. Now I'm going to solve using my order of operations. Negative 8 is hopefully greater than or equal. I divide first. Negative divided by a positive is a negative. Negative 5 minus 5. Negative 8. See if it is greater than or equal. This would give me negative 10. So think about a number line. Negative 8 is greater than negative 10. Smaller numbers move off to the left. So this is true. So then I'm pretty certain that this is going to be the right answer. Last one. Here's my x. I need to get rid of these two numbers. The one I need to get rid of first is the one that's not attached to the x. So I'm getting rid of plus 2. So I'm doing the inverse of addition. I'm going to subtract 2 from both sides. Minus 2, minus 2. That's negative 5. Symbol comes down. X over negative 3. That means x divided by negative 3. I do the inverse of division. I'm going to multiply both sides by negative 3. Again, this is a fraction, so I'm going to make it look like a fraction. Here it's not a fraction, so I'm just going to multiply by negative 3. Negative times a negative. Here again, just like when we divide by a negative, when we multiply by a negative, we need to reverse the inequality symbol. So negative times a negative, positive 15. I need to reverse this because I just multiplied by a negative. I can simplify over here and I get x. So I want to now check. I need to go to 15. I'm going to put 0 here. I'm going to go up by 3's. 3, 6, 9, 12, 15. So at 15, with this symbol, it does not include equals. I need an open circle. I need x to be smaller. So this symbol here, it opens to the greater. So it's opening to 15. 15 has to be bigger than x, or x has to be smaller. Smaller goes this direction. So I want to verify. So I'm going to check. And again, when I look at this, when I'm going to check, the very first thing I'm going to be doing is dividing by -3. So I want to take a number along this line that can be divided by 3 really easily. So I'm going to take 9. So I'm rewriting -3 less than, I'm going to use 9 divided by -3 plus 2. So now I need to solve using my order of operations. And I'm hoping this is going to be true. So -3 is hopefully going to be less than. Now I need to divide before I can add, so that's -3 plus 2. -3 plus 2 is -1. Is -3 less than -1? So if I look at it, -1 would be maybe here, -3 would be here. So -3 is less than -1. This is true. So then more than likely I was correct.